All right, rounding decimals. A lot of students struggled with rounding whole numbers, so rounding decimals isn't easy as well. Rounding with decimals. Decimal numbers can be rounded to whole numbers or to a specified decimal place value. So if we have a number like 18 34/100 and we're asked to round to the nearest whole number, we want to think, is this number closer to 18 or is it closer to 19? And you can think of those fractional values. So 34/100 is how far it is away from 18, but it's 66/100 away from 19. And you could envision it on a number line as well. So, for example, if you owe me $18.34, but came to pay me back and only brought $1 bills, how many $1 bills should you give me if we were to round? It is definitely closer to 18. All right. Decimal numbers can be rounded to whole numbers or to a specified place value. The same number, let's round it to the nearest tenth. So the biggest thing you have to do is decide what you're changing. So you're either saying it's closer to 18 3/10 or closer to 18 4/10. Once you have those choices, I think you can easily decide which one it's closer to. So it's 4/100 away from 3/10 and it's 6/100 away from 4/10. So it's closer to 18 3/10. You can relate it to money again. If you owe me $18.34 but came to pay me back and only brought dollars and dimes, how many $1 bills and dimes should you give me if we were to round? You would give me $18 and 3 dimes. You can round using a number line. It says round the number represented below to the nearest whole number, 1 decimal place and 2 decimal places. So we just see a number on the number line with a dot, but we don't know what it is. But we can still follow these directions. So if we were rounding to the nearest whole number, is it closer to 2 or is it closer to 3? Well, this says 2 9/10, and the other tick mark we can see is 3. So it must be closer to 3 because it's less than 1/10 away from 3, but it's over 9/10 away from 2. If we were going to round to 1 decimal place, we're looking at, is it closer to 2 9/10 or 3 0/10? Well, you can see on the number line, it's much closer to 2 9/10, so it must be 2 9/10 for the 1 decimal place. And then to 2 decimal places, we could count the number of tick marks in there, and we would find that there's a total of 9. So those must be marking our hundredths. So the number that's marked there must be between 2 91/100 and 2 92/100. It must be closer to 2 92/100 just by visually inspecting. Here's another one that you can try. Draw a number line to round the following: 3 24/100 to the nearest tenth. So think about what your choices are going to be for your answer. It's either 3 2/10 or 3 3/10, and you have to decide which one it is closer to. So we can draw a number line with 3 2/10 labeled and 3 3/10 labeled. Then we can label 3 24/100, and we can say, oh, it must be closer to 3 2/10. The only reason we have rounding rules is for when the digit is a 5, because then we can't tell which one it's closer to because it's the same distance from both. So then we had to come up with our rounding rules. What rounding means. So you could have problems that say round to the nearest ones place, which is also the nearest whole number. It could say to the nearest tenths, which is also 1 decimal place. It could say hundredths, which is 2 decimal places, or it could say thousandths, which is 3 decimal places. And if we have an example problem of 23 and 5,471 10,000ths, we would round it to 24 if we were rounding it to the nearest whole number. We would round it to 23 and 5/10ths if it was 1 decimal place or tenths. We would round it to 23 and 55 hundredths if it was 2 decimal places or hundredths place. And we would round it to 23 and 547 thousandths if it was 3 decimal places or the thousandths place. Here are your directions or your algorithm for rounding to a certain place value. First, locate the place value in which you were told to round. Then you determine the digit 1 place to the right of the place value. If that digit is a 0, 1, 2, 3, or 4, you drop all the digits to the right of the place value you're rounding. If the digit is a 5, 6, 7, 8, or 9, you're going to add 1 to the place value you're rounding to, and then drop all the digits to the right of the place value you're rounding. Here's an example. Round the results of the application problem so that it makes sense in context of the problem. You have to be careful with rounding because yes, there are rounding rules, but there's also something called practical rounding, which might not follow the traditional rounding rules, but it makes sense in the context of the problem. So Crystal's buying Halloween candy at a store. She has $20 and wants to buy as many bags of candy as possible. She computes that she has enough to buy 4.87 or 4 87/100ths bags of candy. How many bags of candy can she buy? If you use traditional rounding rules, you would say 5 bags of candy, but she doesn't have the money for that. So if she bought 5 bags of candy, she would be short at the checkout because she only has $20. So this answer breaks rounding rules because she can only buy 4 bags of candy. This is what we would call practical rounding. Here's another one. Jamie is running a booth at a local fair. She computes that she needs to sell 73 and 246 thousandths cones that day to make a profit. Since she can only sell a whole number of snow cones, how many does she need to sell to make a profit? So your choices are either 73 or 74 snow cones. Well, since she has to sell part of a snow cone to make that profit, you're going to say 74 snow cones, even though with rounding rules, you would round it to 73. To really make a profit, she needs to sell that 1 more snow cone for 74 snow cones.